Hey everyone, and welcome to our lesson on parallel lines cut by a transversal. Need to know what that is, so let's talk about that first. Parallel lines, that term means two lines that are never going to intersect because they have the same slope. In this picture, our parallel lines are these lines here. And a transversal is just simply a line that's going to cut through those. So in our picture, the transversal is here. So we've got two parallel lines cut by a transversal. And when this happens, we have lots of interesting things going on with the angles that are formed. And we're going to talk about all of those. First of all, let's talk about corresponding angles. When we see this transversal cutting through two parallel lines, what's going to happen is it's going to create two really congruent clusters of angles, meaning all of the angles here have a matching part here. So the terms here, there's different names for pairs of angles that we're going to see formed by this transversal, and one of those terms is alternate interior angles. Alright, so this space in here is considered the inside or the interior part of the parallel lines. So when we talk about alternate interior angles, they're going to be inside that space, and they are on alternate sides of the transversal. So for instance, 3 and 6 that you see here are on alternate sides of this transversal, but they are inside that space that I was showing you. So these are called alternate interior angles. We have another pair of those seen here, and that is going to be these two, 4 and 5. Alright, similarly, we can talk about alternate exterior angles. So we're not dealing with the portion inside the parallel lines now. We're moving outside or on the exterior portion of the parallel lines. So let's find two alternate exterior angles. They would be on alternate sides of the transversal, but outside the parallel lines. So 2 and 7 would work here. We could also use 1 and 8 as an example of this term. Alright, moving on to same side interior. It is what it sounds like. We're going to be on the same side of the transversal, but inside the parallel lines. So same side interior could be 3 and 5 here, or 4 and 6. Those are on the same side, on the other side of the transversal, and inside the parallel lines. We can also talk about same side exterior. That is going to be on the same side of the transversal, but outside the parallel lines. So 1 and 7 would be an example of that, and also 2 and 8. Now with all of these terms, there are some special things that occur with them. Okay, so we will talk about that when we talk about these properties. Linear pair. So what does linear pair mean? If you see any two angles that are formed that together form a straight line, if I put them together I would have a whole 180 degrees, then they are a linear pair. So we've got lots of examples of those here. 1 and 2. We could even have something forming this line here, the transversal, 6 and 8. We could talk about several pairs here, 5 and 7, 3 and 4. There's lots of linear pairs seen in this picture. And remember, a linear pair will always add up to 180 degrees. Alright, so the properties that are seen by all of these terms. Main things that we'll come across are linear pair, as we discussed, adding to 180 degrees. And the formal term for that is supplementary. When two angles add to 180 degrees, we call that supplementary. So, when we talked about same side exterior angles, those two angles are always going to be supplementary. So any two pair of angles that you find that are same side exterior, those are supplementary. And the same goes with same side interior. So let's look at that again to review. any pair of same side interior are also supplementary. They're going to add up to 180 degrees. All right. Now, we also talked about alternate exterior and alternate interior. So let's look at that again. Alternate exterior. Remember, outside the parallel line space, but on alternate sides of the transversal. Anytime you've got alternate exterior or alternate interior, those two pair of angles are going to be congruent, exactly the same. So let's look at a pair of alternate interior. The yellow here would be alternate interior. Those are exactly the same measure. So let's take a minute and practice what we've seen. If I gave you the measurement of any of these angles, knowing the properties we just discussed, you could actually find every single other angle in the picture. Let's say that we had an angle of 30 degrees here. Angle 2, the measure was 30 degrees. Well, let's think about some properties that we discussed. Remember that a linear pair, any two that form a straight line, are going to add up to a straight line, 180 degrees. So if I know 2 is 30 degrees, then I know 1 should be 150 degrees. They have to add up to 180. And I can work my way around this picture knowing that just that one property really. 2 and 4 are going to be a linear pair. So since 2 is 30, I know that 4 is also 150 degrees. And moving right along, I'm going to work my way around to angle 3, which should be 30 degrees for the same reason. Now I could move down to this next cluster of angles, 5, 6, 7, 8, and do the same thing, but let's practice some of the other properties we talked about. So knowing something that we discussed about same side interior angles, we said those were going to be supplementary. So let's look at an example of same side interior. If these two are supplementary, then I know they have to add up to 180. So knowing angle 4 was 150 degrees, that means angle 6 should be 30 degrees. And now you can use any of your properties to work your way around this picture and find all of the other angles. And you will come up with these same measures here. And that concludes our lesson on parallel lines cut by a transversal.